Hello, my name is Nate Lohmeyer, and today we're going to be going over problem 1 for the Thermodynamics ePortfolio or Tempo project for the summer of 2014. Okay, so on this slide is the problem statement, which I'll read now. Balloons are often filled with helium gas because it weighs only about 1/7 of what air weighs under identical conditions. The buoyancy force, which can be expressed as Fb equals pgv, will push the balloon upward. If the balloon has a diameter of 12 meters and carries 2 people, 85 kilograms each, determine the acceleration of the balloon when it is first released. Assume the density of air is 1.16 kilograms per cubic meter and neglect the weight of the ropes and the cage. So for this problem, we're attempting to find the acceleration of the balloon when it is released. We're neglecting the weight of the ropes and the basket and the material that the balloon is made out of. So we're going to write down some of our things here. We have the diameter of the balloon equals 12 meters. We have 2 people times 85 kilograms, which is equal to mass of the people of 170 kilograms. The first thing we want to figure out is the buoyancy force, or Fb, which, as stated, is equal to density times the gravitational force times the volume of the balloon. So the volume of helium was given to be 1/7 the density of air, which was 1.16 kilograms per meter cube. So we know that. We also know the gravitational constant in the metric system is 9.81 meters per second squared. So the last thing we have to figure out is the volume of the balloon, which is simply 4/3 pi r cubed, with r being 6 meters. So the volume of the balloon is 904.78 cubic meters. Okay. If we were to draw our free body diagram of the balloon, simplified, we have the buoyancy force, Fb, which we just accounted for on the previous slide, minus the weight of both the helium inside the balloon and the people. So we know the mass of the people, 170 kilograms. We now need to find the mass of the helium, which is simply equal to the density of the helium times the volume of the balloon. We found the volume on the previous slide. The density of helium is 1/7 the density of air, which is 1.16 kilograms per cubic meter, times the volume of the balloon, 904.78 cubic meters, and we plug that in and we get the mass of the helium, which is equal to 149.93 kilograms. So the total mass or weight of, that's the total mass of the helium, excuse me. So now we know the total mass of both the people and the helium is 149.93 plus 170 kilograms. So the total mass is equal to 319.93 kilograms. We can now take that times 9.81 meters per second squared, to get the total weight. Which is 3,138.5 newtons. Okay. Now that we've solved some of these preliminary steps, we'll use Newton's second law, which states that the sum of the forces equals mass times acceleration. And remember that acceleration is what we're trying to solve for. So using our free body diagram from the previous screen, we'll have FB minus the weight total equals mass times acceleration. Okay, subbing in, we have density of air times G times the volume minus mg equals A, this whole quantity divided by m. So if we were to plug in some numbers here, we'll have 1.16 times 9.81 times 904.78 minus 319.93 times 9.81. This is all divided by 319.93, which equals our initial acceleration of the balloon to be 22.37 meters per second squared.